Hey guys, this is Coach Lowe, and we're going to talk a little geometry again today. This is Chapter 5, Section 5, the triangle inequality. So we are going to look at Theorem 511, and you could go ahead and copy that down in your notebook if you want to go ahead and pause the video, grab your book, and copy Theorem 511. It's a triangle inequality theorem. I'll go ahead and talk through that, and you can choose to pause when you need to write it down. The triangle inequality theorem says the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So the sum of the lengths of any two sides in a triangle have to be greater than the third side. All right, so let's go ahead and set this up. Let's say this is ABC. Then we have three sides. We have side AB, and we have side BC, and we have side AC. So we can take any two of these sides, and the sum of those must be greater than the third side. So the length of AB plus the length of BC has to be greater than the length of AC. We could take any other two. AB and AC has to be greater than BC. And then the last ones, BC and AC, must be greater than AB. All right, that has to be true. Okay, so let's explain this. Why, if I give you these three measures, why could this not be a triangle? Why could these measures not be side lengths of a triangle? Or could they? All right, so you can take two sides and make sure that they're greater than the third. So you'll pair up these two, pair up these two, and then pair up those two, and they have to be greater than the third side. All right, let's just start with 6½ plus 6½ has to be greater than 14½. Well, 6 and 6 is 12, and 2 halves make a whole, so 12 plus 1 is 13. Is 13 bigger than 14½? Nope. So these cannot be sides of a triangle because this is not true. All right, let's try one more. What if I gave you 6.8, 7.2, and 5.1? Could those be sides of a triangle? So we'll pair these two, and then 1 and 3. So first and second side, second and third side, first and third. All right, so 6.8 plus 7.2 has to be bigger than 5.1. Well, yeah, because 6.8 is bigger than 5.1, so that one's okay. 7.2 plus 5.1 has to be bigger than 6.8. Again, 7 is bigger than 6, so that one's okay. All right, so 6.8 plus 5.1 has to be bigger than 7.2. This might be the iffy one, but 5 and 6 would be 11, so 6.8 and 5.1 has to be bigger than 7.2. So yes, these could be side lengths of a triangle. All right. So let's look at another triangle. Let's look at triangle PQR. And I'm just randomly sketching a triangle, so this could be not to scale, and that's totally fine. So let's say that this is P, Q, and R. Let me change these around because this will really not be to scale, and at least I could start out drawing it correctly, right? So let's make QR is going to be my smallest side. So let's do this. So 5.2 and 7.2. I have two R's on there, so this should be a P. Hello. All right. All right, so QR is 5.2. RP is 7.2. So can you tell me in general what the length what the length of QP could be or could not be? Well, we know that these two sides have to be bigger than this side. So 5.2 plus 7.2 has to be bigger than QP. Awesome. All right, so that means 12.4 has to be bigger than QP. All right, so QP cannot go over 12.4. If I flip this around, it would say QP has to be less than 12.4. So as long as it's not like 12.5, 13, as long as it's not bigger than 12.4, we would be okay. So if they gave me some options, like A was 8.5, B is 9.2, C is 11, and D is 13.1, and they ask you which of these would not work for QP. You would say any of these could work because they are all smaller than 12.4, but 13.1 would not work because it is bigger than 12.4. All right, let's keep rolling with this. If you have your book with you and you would like to look at some of the problems, that would be great. Then just make yourself some notes on ones that you're like, yeah, I don't know if I could do that. We could talk about those when you get back to class tomorrow. So, or if it's a weekend, then the next time I see you, I should say. Let's draw a picture here, and I'm going to give you a little scenario, and let's see if we can figure it out. All right. So let's talk about traveling. Towns of Jefferson, Kingston, and Newberry are shown on the map below. So this is Jefferson. This is Newberry. And this is Kingston. All right. Prove that driving first from Jefferson to Kingston, so this direction, driving from Jefferson to Kingston, and then Kingston to Newberry, is a greater distance or farther than just driving from Jefferson to Newberry. All right, so these, we know that this side plus this side has to be bigger than the third side, right? So we know, let's just say that this is J, K, and N. We know that side JK, or that route, plus traveling the route from K to N, so Jefferson to Kingston, Kingston to Newberry, is going to be longer than Jefferson to Newberry. Awesome. Very cool. So we use the triangle inequality theorem to prove which direction we need to drive for it to be shorter. Although this could be a more scenic route. I mean, who knows? All right, guys. We'll talk more when I see you again. This is Coach Lowe, and I'm out.